Okay, so we are going to I'm going to start the introductory lecture और इसके बाद आपके ना बेसिक बहुत से कॉन्सेप्ट जो है ना वो क्लियर हो जाएंगे, ठीक है। और बाकी जो कुछ रह जाएंगे हम उनको आपको जब आप क्वेश्चन कर सकते हैं रिलेटेड टू दैट जो है मैंने बहुत सी चीजें आपको बेसिक वाली अभी बता दी है, राइट। ओके, लेट्स मूव टू आई विल ट्राई टू एक्सप्लेन इन दिस नाउ लेक्चर दैट व्हाट इज बीम, ठीक है। बीम है क्या चीज, ओके। ओके, व्हेन वी टॉक अबाउट द कंस्ट्रक्शन इंडस्ट्री, राइट, it's not something new, right? अगर आप लोग Irami Misr 4,500 years ago, right? Even before like 2,500 years before the birth of like Hazrat Isa alayhi salam, right? So imagine like how these big infrastructure was built, right? And then this structure, right? In the 2,600 years ago, right? This was like Mesopotamia, right? And then 2,200 years ago, the Great Wall of China. So these different type of structures human has been building a different type of structure, right? वो इंसान गारों से शुरू हुआ, then it comes towards the फिर क्या हुआ, इंसान ने घर बनाना शुरू किए, then it was some also during the wars, ठीक है, किले बने, right? And then to show the mightiness of any kingdom, right? And also Great Wall of China, who knows what was the purpose of that, but in that part of the world, generally they have the walls along the city, right? ताकि शहरों को protect किया जा सके, right? Similarly, I'm right now living in South Korea. We have old Seoul City Wall, जो कि शहर के चारों तरफ एक पूरी दीवार है जिसके ऊपर different gates हैं और to protect the cities from war. So ये कोई new industry नहीं है for humans. This has been over, it has a big history. And construction में या architect में या किसी इंजीनियर के लिए सबसे important चीज क्या है? We know that the dimensions, and we know the design, and then the construction part comes, right? So because to make it like precise what we are imagining, so it keeps on evolution, right? It keeps on evolving. हम लोगों ने सर्विंग थी पहले जनरल और टेबल के साथ और बेसिक आपके ऑप्टिक्स के ऊपर बेस्ड थी. Then we got the total stations, and now we have the drones technologies for surveying, right? So this industry is continuously evolving, and now we have the robots working with humans for the construction of the construction industry, right? So construction industry is slow to change, this, as you see that एक कंस्ट्रक्शन मैनेजमेंट क्यों इंपॉर्टेंट है या कंस्ट्रक्शन को हम ऑटोमेशन या बिम की तरफ क्यों लेके जाना चाह रहे हैं, राइट? दिस इज वेरी इंपॉर्टेंट, राइट? हम लोग क्यों बिम को या कंस्ट्रक्शन ऑटोमेशन की तरफ लेके जाना चाह रहे हैं? एक्चुअली कंस्ट्रक्शन इंडस्ट्री की प्रोडक्टिविटी स्टिल स्टिल जो है ना वेरी लो एज कंपेयर टू अदर फील्ड्स इन द वर्ल्ड और एज कंपेयर टू द मैन्युफैक्चरिंग इंडस्ट्री, राइट? फॉर एग्जाम्पल आप ये चीज देखें कि अराउंड 1910 से लेके, or we call it the industrial revolution, last century, right? So people used to make the cars in 1910 to 1930 to 1940 before the First World War, right? And now we have robots who are constructing the car. So what is happening is that कि हम लोग के पास robots आ गए and the process and the productivity becomes very high, right? Whereas construction 100 साल पहले, 200 साल पहले, 500 साल पहले humans were making the bricks and they were trying to that. और आज भी humans कर रहे हैं. So आज हमारी productivity still हमारी productivity construction industry की low है, right? So BIM, automation, robotics को introduce करवाना construction industry का main target हमारा यही है कि we are going to make it as like a manufacturing industry, right? This is the biggest challenge which BIM or all the other modern technologies which are trying to solve that, right? Okay. Now, how to improve that productivity, right? So these are the latest technologies or latest techniques which has been implemented in the construction industry to make it as productive as the manufacturing industry, right? हमारे पास we have prefab and modular construction, advanced building materials, 3D printing and additive manufacturing, autonomous construction, virtual reality, big data analytics, AI, wireless monitoring, cloud real-time collaboration, 3D scanning and photogrammetry, building information modeling. So these all are different tools. And generally all these tools I will be covering in that postgraduate diploma. I will be talking about advanced building materials, prefab, autonomous construction, virtual reality. In this world, आपको आज के दौर में you can get more information, but if you don't have the knowledge, that's a problem. अगर आपको पता हो कि ये प्रॉब्लम सॉल्व कर सकती है, how to solve that problem? You can easily, go and you have a lot of things, right? So, okay, next slide. So and also BIM is one of the most important part in this, all the most promising technologies. For example, if you talk about AR and VR, they are linked with BIM. If you talk about 3D scanning, they are linked with BIM. Cloud computing is linked with BIM. Prefab is linked with BIM. 3D printing is linked with BIM. So everything is also linked with the BIM. So it is very important to understand the importance of the BIM. So when we talk about the building information modeling, actually it tells us that now we are adding information for our modeling, right? So building information modeling was basically adopted for the mechanical engineer, and then it was adopted in the civil industry, right? And also it's not something, BIM is basically uh art, you can say that humans हमेशा visualize करते थे things, right? So even you see a cave art in Spain, 15K BC, like there we have the Ice Age cave arts, so these cave arts are related to some human where he is thinking to send some message or thinking about some creation, right? So BIM is a very latest version what the humans thought about the 15,000, like a 1400 years ago. So we can start that it's like a 13,000 years of a journey, right? For example, we have a caves, so human was thinking about how to make the cave. So he has that design in his mind. And then we have that art, early 10K BC and still in 20th century, we have that art where humans try to draw things. Then we had the board, which was in early 18th century, still in 21st century, where we are trying to make things, based on the board and draw that stuff. And then like board means that we used to have the design drawings made on the by handmade, right? हम लोग पहले we are using the different mathematical tools. Then it becomes a computer aided design. Since the invention of computer, no, it become more easy for everyone to make the drawing on the computer, right? So it was a 2D plan. We can say that जो चीज हम लोग पेपर के ऊपर बनाते थे इसको ट्रांसफर कर दिया कंप्यूटर एडेड के अंदर. So when the computers become a part of our life in 1980, so then it become also part and adopted by the construction industry to make the designs. And then late 20th century, and of course in 2020, in this 21st century right now, BIM is really an integral part of the construction. No, it is widely adopted. If you see its journey, all the companies ask you, now अब क्या हुआ वो 2D drawings को उस 3D के ऊपर imagine करवा के कि ये कैसा लगेगा before the construction, फिर उसकी simulations कि construction कैसे होगी. This is now what we are having. So it's a continuous evolution, and also the humans always looking for better solutions, right? So this is a BIM timeline. Like I mentioned before 1980s, we used to have the draftmen. So there are a lot of draftmen, working on these big drawings, become a draftman, enjoy a real job in the industry. And they were like very good. Imagine if you're going to make this big drawing, so how hard they're working on that design, or either you are making a multiple copies for you. Maybe you have a couple of architects who are trying to make the same copy because you are sending to different stakeholders. You know that. And now we have also multiple craftsmen also work together from electrical, mechanical, civil engineering for making all these big buildings, because we have a couple of like, big buildings even from that era in Industrial Revolution. In America, we have a big steel structures after the First World War, or even before the First World War, right? And from 1980s, with the advent of computer, we had a computer-aided design, right? So this all knowledge was getting transferred into the computers, right? So building design were digitized during the 1990s, and then we are undergoing to a continuous change towards the model and design base, right? So the first time the concept of building information modeling, was from Robert Irish in 1986, right? अब ये चीज देखें, आप खाली अभी देखें, आप ये हमेशा एक चीज को याद रखना कि आप दुनिया के या हिस्ट्री के किस पॉइंट पे एग्जिस्ट करते हैं. इट्स इंफॉर्मेशन मॉडलिंग, राइट? इवन CAD was at that moment was information modeling. आपकी line की dimensions providing you information, right? Now it become a 3D, you know. So no, आज हम 3D को contemporary कह रहे हैं, right? Similarly, मैं एक चीज अक्सर अपने robotics वाले कोर्स में बताता हूँ कि आज से 60, 70, 80 साल पहले we can say that excavator is a robot. The definition of a robot is very simple, right? Who helps humans to do work more productively. But now today we cannot consider excavator as a robot. Now we want something which is self-intelligent doing its task and being more productive. So at the contemporary movement, we can define the definition of that. So today we think that when we're talking about BIM, it should be minimum at least third like 3D with information embedded in that. Again, this is a really important like slide. Okay. When someone say about BIM, it's different, for everyone, right? It's similar for an elephant, standing in front of a different people, right? And now all are blindfolded, right? And they are allowed to touch the elephant. So if someone is touching its tail, it says it's a rope, right? He's true. He's true that it's a rope. And a person who is touching his belly part, he thinks that it's a wall. He's also true because he feel like it's a wall. And some person who's touching his ear, he feel like, oh, it's a fan because it feel like a fan. And someone who is touching the front leg, he believe, oh, it's a tree. And someone touching his trunk and believe it's like, it's like a snake. And someone touching the spear, it feel like the teeth of the elephant, you will see that, oh, it's a spear. So BIM is something similar, right? We cannot contain BIM, or it's different for everyone in a different perspective. It's different for electrical engineers. It's different for mechanical engineer. It's different for architectural engineer, construction engineer. It's different for mining engineer. It's different for petroleum engineers. So we is the BIM is that everyone think in a different perspective and they all are true and right. So this is a best example of BIM that everyone is blindfolded and they know only very good about their part. So this is a BIM, right? So what's the definition of BIM? That's very important. What is BIM is, actually it's a process. We cannot say modeling, it's a process to create intelligent 3D models that enables document management, coordination, simulation of a project life cycle, right? To make you effectively plan, design, construct, and manage building and infrastructure, right? Okay. So basically a process it's not like 1+1. So it's a process, So when I say it's a process, so it means that कि एक प्रोसेस है डिफाइन किया फॉर अ स्पेसिफिक प्रोजेक्ट जिसके अंदर हम लोग डॉक्यूमेंट्स के मैनेज करेंगे, कोऑर्डिनेट करेंगे और लाइफ साइकिल के थ्रू effectively management of a project to be in precise way, right? So BIM is an integrated process creating and managing all the project information, right? And it can be different for a mechanical engineer, it can be different for a civil engineer, it can be different for architecture engineer. It's same operation, design, and construction, right? For us. So when we talk about BIM, this is not BIM. This is only a 3D or graphical information. Oh, sorry. So this is not a BIM model. This is only a 3D model. So when we add a graphical information with it, then we can call it, a BIM,
Excuse me, sir.
right? Gigi.
Sorry, slide
Your
is not
screen is
visible.
not shared now.
Okay,
Slide
wait,
show.
wait, wait. Okay, wait.
Put
Let me
down.
see. Maybe there was some technical issue. No, it's shared again. Let me
Yes,
know when you
yes,
see
sir.
it.
Yeah,
Okay.
yeah, it's
Thank you
But
very
it's
much.
visible,
Okay.
sir.
ओके वेरी गुड ओके ठीक हो गया सो अगर आप ये वाली पिक्चर देखें सो वी कैन नॉट से दिस इज अ बीम दिस इज जस्ट अ 3D मॉडल now you can create a 3D model on your mobile phone. A 5-year old kid can make a 3D model, right? So this is not a BIM. This is only a graphical information. When we add a non-graphical information attached with it, then we call it a BIM, right? So this is a big misconception. A 3D model is not a BIM, right? And now making a 3D model is not a big task. When we were a student in like 2009 or 10, we used to like extrude the things in AutoCAD to make it, it was no, it's very easy. There are a lot of like SketchUp or there are a lot of software where you just tell them what to do. Like in Revit, you have to select the component, you got my point. Even sometime I will go back and I see my 2010 survey project where I try to develop our if someone is from UT Lahore, he know that chemical department has very good building. So I try to using in our survey class, I make a 3D model of that. It was really hard to make that. So now it's very easy. So when
Excuse
we
me, sir.
talk about Gigi,
Sir, please can you repeat the difference, sir? I cannot get it, sir. The
sorry,
difference
which one?
between BIM and 3D. So the difference between
Gra
BIM and 3D model.
BIM and 3D model, okay, right, okay.
Yes.
ग्राफिकल मॉडल आपके पास क्या एक मॉडल हो सकता है फॉर एग्जांपल ओके फॉर एग्जांपल इफ यू मेक आई एम होल्डिंग दिस ग्लास ओके आप इस ग्लास का 3D मॉडल बना सकते हैं राइट इट्स अ 3D मॉडल वी कैन से इट्स ओनली अ ग्लास राइट ठीक है सो ये ग्लास तो है अगर आप इस ग्लास का 3D मॉडल बना देते हैं और ये स्केल पे नहीं है पहली बात स्केल समझते हैं ना अगर ये स्केल पे नहीं है तो ये एक 3D मॉडल है राइट इट्स अ 3D मॉडल इट हैज नो इंफॉर्मेशन अब हम इसके अंदर इंटीग्रेट कर दें दिस ग्लास इज मेक ऑफ स्टील राइट this glass has this much diameter this glass has this much length right we are adding the non-graphical information in that you got my point right कि
Yes.
ये किस
Thank you. I
कंपनी का
got
है स्टील किस स्ट्रेंथ का है we are adding all this information then it become like a BIM model, right? I just give you a simple example, okay? So this slide is the same, okay? BIM is an object-oriented parametric modeling. We have the product data, as I mentioned you, like, this glass is made up of steel, right? Where this steel from? Which company has made this steel? What's the gauge of that steel? You know, all this stuff. It's similar in construction. You have a lot of building materials. Which cement, coming from? What's the strength of the cement? What's the steel? Even your, all these designs. So you have a detail. What's the cost of that? You integrate that with the product geometry, then it's called the BIM object, right? So this is a best slide to explain that, that thing in detail. And also know the problem is that before the paperwork, the traditional document process is really, really cumbersome or it's really, really hard. I have worked at that moment, in a like I told you, a $5 billion project, or still the BIM was not adopted. I'm talking about 2013, right? So it was really hard sometimes. I still have all this information in scanned form. I'm going and sometimes I want to use that and look at some information. It's really hard. We have all these scanned documents. Even, one we had, I remember like more than, I don't remember actual number, but I remember some drawing, 9,000 drawings of like, only one underground powerhouse. You understand, related with that. So अगर आप एक component देख रहे हैं उस component cross section के लिए you go to another drawing. So it was really hard. Or information आपकी exchange होती in terms of paperwork, which was like adding more value, data loss, and errors. So this was how our traditional document process works. But BIM, what? Why we need BIM? So what BIM does, basically it helps to have the 3D information in XYZ in one model, right? So you can cut the section at any point where you want, you can click on the component, you have all the information about that, you know. So largely, our traditional drawings are 2D based, and it's not very easy to understand. As a structure engineer, you people know that how it's hard, when a structure, after even having a bachelor's degree, when first time you go to the construction site, and you have to check the steel design, it's really hard, because it's not like checking is hard. It's really hard to understand their 2D this 2D drawing of the steel, so and when in a mega project, when there's a complex design, it's really hard to understand. So if you have a 3D model of that, you understand, and then you can compare with that. And now with automation, now we have a lot of other tools where they're automatically checking the design and matching with as-built information. So, so the main difference between CAD and BIM is that BIM is intelligent associated with every element in BIM, right? Which is I explained you before, okay? Whereas CAD was only a two parallel lines, and it has no information about the structure, right? Right? Which I'll tell you. Okay. On the other hand, as I mentioned, give you the example of the glass, the steel glass, it have all type of information embedded in that. So this is the components. The CAD components can be a straight line, circle, arc, ellipse, or anything. They are only lines. Where a BIM components can tell us wall, floor, we have the dimension, we have the information about the even the materials. So BIM can also have the intelligent objects, right? So for example, you know that, oh, we have that information. You see that, you open that. What are the paramedics? What are settings? What are the model? What are that? Even you add the cost into that. And similarly for the clash detection, you know that if there's a clash detection of one MEP is clashing with other MEP, we know that. Or also your construction scheduling is overlapping with that, or your construction material are not overlapping well, or you think that these two construction materials cannot be good together. So we know about all this stuff before even the commencement of construction. So this is a simple CAD plans, where you see that, oh, it's a 2D drawing, and you see the sections, which I told you. In case of 3D, you have all these components can pop up, even you can rotate it, and you can visualize it better, And also there is like a coordination of changes. You know that one of the biggest cost in any project is we call it, design changes, right? During construction, you know, that's really a problem, because sometimes the clients are, or most of the time, the clients are not the technical guys, right? You know, so the design changes, they don't understand what you are trying to say through the design. Now the client can also understand very easily, what he want, uh, from the engineer. So BIM can also helps to coordination of the, between the stakeholder. And also if there's any design or change need before the construction, we can have the better coordination how to change the things, right? Like for example, in this we have the stairs with metal construction, right? So it have all the details, like how it is that in length and everything, and it has a 3D model. Even we can have the simulation, like in Korea they do that, because this is very important. Even the apartments who are getting the most sunlight, they are more expensive, right? So you see that we can do even the energy analysis, we can even use the sunshine analysis, so it can give us like based on the 4D simulations, based on the time domain. You can see the shadows, like at which time, what shadow we can have, right? How it look like in what time throughout the day. Then we can also have the optimal designs based on, it can be either based on our environment. It can be either based on our energy consumption. It can be either based on the, requirement of our client, or statistics, right? So, so it can give us a better communication between the designer, client, and also the construction guys. I please ask me this question at the end of the, no, we have a question at the end of this lecture. All right. Let's keep it for that. Okay. When we talk about the BIM process, right? BIM is BIM isn't just a 3D, okay, or CAD or a design. Actually, it's a process, right? So now it's a life cycle. Okay, BIM is actually a complete life cycle where we have all this information and we store it for the whole life cycle. For example, you start from the concept. Once you make a concept, and then it is based on different LODs. Okay, when I teach the course of BIM or data informatics, I go in detail about that in detail, right? So that what type of information you need at which point of the project, right? We have a conceptual design, and then you have a design and then detail design. Then we do the analysis and then we do the scheduling. So during the design and engineering phase, we have the whole process of that. And then in the second part is fabrication or construction, right? We construct or we make the product. Okay. When we are now talking about the fabrication and construction as well, because now we have the prefab construction going on. In my course in construction innovation, I go very detailed about the fabrication part as well, right? And then you hand over that part to the client. And next is the operation and maintenance. Now the problem is that now we once we hand over the facility, now all this information is stored at some place, and now there is some maintenance or operation during the operation task. We have a lot of problems. Generally all these mega projects, they need a lot of like operations and maintenance. This is like and also like all the developed countries there, when their structure gets aging, there's a lot of cost related to that. Or if you want to renovate the facility, so you have all this information throughout the life cycle where you can use the information to do a lot of tasks, right? Or even after renovation, maybe it can lead to demolish. If we want to demolish the facility and we want to make another facility, you still have that information about the geotechnical information. How was it that, and what type of material it has had? You can maybe which is a reusable material from that, so you can do that. So, we have, even that question will be no answer. That's why I say we will have answered at the end of the this session now. We have consultant now. BIM integrates everyone. It integrates the architects, it integrates the construct consultant and planners, building owner and facility manager, and system integrators, right? So basically architects are, if you take it that way, architects design or they give the concept, okay, of the building. But now BIM can add the concept of civil engineer in that, where you can do the structure analysis before even the building is built, right? So, and give the feedback to the architect, because the architects only mostly care about, not only like mostly care about the aesthetics part, right? Where the architectural engineer or construction engineer, they have to also think about the facility, right? In BIM, we can do a lot of analysis and get a feedback and give the feedback back to the engineer, to the architect, if you want to do some design change, right? Similarly, the constructor or planners, they can have their part in that. Like, oh, we have a time domain for this project. We have the budget for that. So they can integrate, okay, this design is not feasible in that much money. How to arrange that budget, right? So this is all, everything is integrated in this process, right? And BIM isn't it for all large companies or mega projects? This is like a very like a wrong myth about that. It's mostly about for all and every project. Even a small product can be a part of the BIM. Even for the making bricks, if you can adopt BIM, it can be more accurate and it's more productive. So the BIM is not only for the companies. Okay. No, from the process of modern civil engineering in higher education. Now you see that the time required for processing, what was it like? There's a concept, documentation, and coordination, right? So this is the time required for processing. In the beginning, the concept was very easy, and we are at documentation stage. We spend a lot of more time there at that the documentation and CAD part. And then you are in a coordination part. it goes like a time requirement, right? We have a time, so we are actually spending more time on the documentation part because it's really hard, but in case of BIM, 50 to 80% of total time, of the time, time requirements at the early stage of project. So what it helps, if you have some error or if you have some problems, we can sort out at the early stage. And at the documentation and coordination, we are spending less time. So we are spending less time in the documentation and coordination phase. This means that we are improving the productivity of our our project or our process. Now we can say that there are several different dimensions of the BIM. When people talk about the dimensions, okay, for me, I make it very open. Like for that, I make it fixed until the 5D, and 6 can be anything onward, right? For example, the 3D is the representation of a building, integrated with the information of a product, right? Which I told you. If we add a time domain in that, we can say it a 4D. And now if we add a cost domain in that, we can say it's a 5D, which helps to calculate the cost and adjust the budget, right? 6D. Now, 6D can be anything. Now, other dimensions are flexible. For example, I can say that, oh, my 6D is the virtual reality where I want to visualize the BIM in a virtual environment, okay? Or six, these are the generic terms. Okay, it can go until 10D or 11D or 12D. But generically, civil engineering, when we talk about 6D without mentioning, it means that operations, considering facilities management. 7, we talk about the sustainability, where we provide the environmental energy efficient solutions. And in 8D, we will include the safety and emergency plan and prevent the security issues. I can say like a 9D can be like adding the sensors information and giving the feedback to the BIM model. 10D can be the VR. So we can add as much dimensions as that. So when I told you about the visualization, so this is like a 3D model looks like. So a 3D model is like a simple object that builds off the information model. Like, okay. So this model represents the building or building spaces in a virtual environment, because this is when we talk about virtual environment, it can be two types: immersive virtual, non-immersive virtual. Okay. When we use a VR, it's immersive virtual. What we see on the screen is also a virtual environment. We call it non-immersive, but it's also a virtual, right? So you can see that. And it has the minimum length, width, and the height. Right? So this is also just a example where you can use BIM, or like, where you can have this and then you mark everything in a BIM project so you can visualize what you wanted, after that, what is your future plan, right? Or for is something similar, like, you want to have like the underground new facility, you want to install a new underground pipelines, underground facilities. So you know about that, what our previous facilities are, how it's going to work. So this is our, better understanding of the environment in a 3D way. Similarly, these are the for the road project, you can have the better understanding of the, how our, like these type of, junctions or interchanges. We call it ICs, right? And even in Seoul, because it's one of the big cities, like, 50% population of Korea lives in one city. So we have so many complicated, ICs. So sometime when I'm going there, even as a driver, I will like really, oh, the people who have designed it have gone through so much thinking. In America also there are like junctions with a lot of like ICs, interchanges. So this is simple, like, you can see that information, like, okay, it contains each and detail about that, and even you can inspect each and every element, to a very minor level, right? So this is like if you see this example, you can see that we have the different structural elements and we have the 3D model. Even in BIM, if you want to see, we can have the plan view, right? So let's have this video, and now you understand that. Design your model in 2D or 3D, And you can see that you can have all this information is going in real time that can also quickly build your 3D model. And this is what BIM can help you. And then you can see your floor plans, you can see your cross sections, your elevation views, isometric, all different type of views in, very quickly. And then you can even render your things very, very quickly. Now our computer has become better. I know that like 2009, 10 or 11 at that moment, even doing a rendering for a small part, it take ages. So also the computing has become better. So design your architectural models in 2D and you can make the changes in real time. So there's a lot of catalogs of all these HD materials. So this is all you're going to learn, in your this course. And this is one of the video, like, showing that part, right? So how you can put, and then you can generate a detailed cost, cost estimate automatically. Right? So now this is also one of the videos. This is also one of the videos where you can see the basic. Sorry, let me play the video. Okay. Here now, this is like an immersive environment. Like on immersive, non-immersive, or either you can have this environment, virtual environment where you can have a walkthrough in the environment before even the construction has been done. So this is what we said as a BIM. Right? So these are the examples where we want you. Now look at this, another example. So you see that, there is a lot of like MAPs and a lot of stuff in the general, in all these buildings. So you can have a detailed, design of all these things. So even for facility management, you know that which part is where. And even before the construction, you can have the clash detection part, right? For example, like this is like a part of MEP, and this is part of civil construction, which we call the beam, right? The steel beam. And now if they are intersecting the design, so we need to know that, okay, we have to discuss with the civil engineer, with the mechanical engineer. So they tell you that thing. Prior to that, we have a lot of these things are solved by, the design changes. Even you can see the clash detection here, right? So this is also another example of that, right? You can see this like a lot of stuff, that even the two pipes where they have to match and they are not matching. So for example, look, you see that? So you can see the collections there. And actually, after the clash, you can see also the clash detection. What type of clash detection was that? What was the idea of that? And who is responsible that? And who is responsible for that? And we can make these two stakeholders to solve that problem. It's very easy, right? And also look at this. So so the BIM allows us to have a better visualization throughout the life cycle of a project. And to analyze. Look at this, in 2D drawing, someone can build it like this. But with 3D model, you have a better visualization. Apparently, if you see the 2D section, it can be possible, right? It doesn't make sense wrong, right? What is now the 4D BIM, right? So we had discussed about the 3D model, right? Now we are linking this with our project scheduling, right? So where we know that like how much information and how much construction we will have at the what part of our plan, right? So it will show us, okay, this much is constructed at 23rd week, this much is constructed at 45th week, And this will we will look around 46 week. And this is what we can show to our client. Like you will have this type of thing, right? And also there are a lot of other trades we are engaged with that. So he know that okay, when we have to have our paint guy to be available there, and there a schedule change, so he understand which person has to come on what time. And actually, in this postgraduate diploma, you will see the Vico Office, Synchro, and also the Nevis work, right? Now the project or Primavera, also you can link with project Microsoft Office project and Primavera with the BIM. Actually you're going to learn these softwares as well, and also you're going to learn about these different simulation software of BIM. So they can be integrated. So you will also learn how to import this data from one software to the data, and you can link with this with the 3D information. Okay. So now we can add, you can see that this is now you can see that we add all this scheduling part here. And now you can see that how it looks like generating more accurate program information, enabling step-by-step visuals of object development. Right? So हम लोग को वो चीज विजुअलाइज नजर आ रही है पहले से कि हम लोग कैसे it will construct, right? So 4D BIM include planned versus actual schedules, time-based clashes, site utilization, and planning. This will really help us to do that, right? So this is how we can link the PMI, our Microsoft project software, or our Primavera with the our you know our You see that? Okay. Now you can see, right? So how the scheduling is linked with that. So you can see how the scheduling is going in real time, integrated with CMPM scheduling information. So it shows us the monthly or daily in the progress. Construction scheduling techniques. We have different bar chart. We have the critical path methods. In NUST, I used to be. I was teaching the construction project management course. So with the linked data of the graphical information of the component system, it becomes easy to understand. And also query project information, and also it's possible to show how construction will develop and sequentially over time, showing how accurate structure will visually appear at each stage. We can add the sequence in that. We can also understand, and and the team also understand what component or what part has to be finished first, and it provides a better communication, right? Now when we're talking about the 5D BIM, I already gave you the basic information about like basic understanding. Now when we talk about the 5D, it means that we are integrating the cost component in that, right? So it's a 3D design model. We add the time information, and then we add the 5D, we add the cost information, right? So drawing on the component information model based to extract accurate cost information, what's the best at the heart of the 5D BIM. Now we also include the cost with the components now. Now we have scheduling. Even we can know the cost at any point. Of course, there were the softwares before, like the risk analysis, where we can do the primary risk analysis. We can have the cost of the project. But here, at any moment of the cost, we know that what components were installed at that moment, how much money we needed, right? Even it can help us to have 5D modeling, estimating in addition to the cost information, right? For example, if you see that video, you see that now we are getting the cost projections. So we can see that like February, what type of cost, which components we need more cost, where we are spending more, are we spending more on material, what type of that. So this is like you can or we are spending on the artwork. So it can show us all this information, and you can see that it shows us our budget or cost information. If we are doing the foundation work, our cost is different type, and how much budget is consumed. So this video can show us all in detail about that. we are doing the excavation part, and in excavation the earthwork has the most, the highest cost. Then we have the tower crane. Now we have started with the foundation work. So we are having a scheduling. It should be like, we have the new year is coming. Now the third phase. Now we are starting the main works, and you can see how the cost is fluctuating along with the time. After we finish the main work, and then we will move to the, you can see how the phase is going, right? The phase T is the, like, you are finishing all these main works, and now all this, like, concrete and the slabs and the column beams and everything is constructed. Now we can see the floor plans along with that, and this is our construction phase is going on. You see, we are now precast concrete, and now our third phase is like completed. And you see where our cost is. Now we have the main cost was here, and now we have the interior fit out, where we are going to put the, now you can see the information of the cost of, like, how cost is like going, basement is complete or what. So so the BIM can help us to understand all this information, right? So So basically, BIM can help us to effectively manage, operation maintenance, sustainable goals, occupant comfort, space management, repair, and innovation. So the sixth dimension of a BIM is devoted to facility management and focus on leveraging the model to information to reduce owner's cost over the life cycle of a facility, right? So actually, 60 means we can also call it like the asset management, because we consider it as an asset, right? So actually, BIM embedded operation and maintenance manuals, concept, computerized building record and database. So it's very easy to get the record. For example, if the one component is like malfunctioning, we know that, okay, who was the manufacturer of that? What was the dimension of that? When we have installed that first time, if there was any maintenance operation was conducted. So we have all this information. And if we want to replace that, we know that who was the manufacturer of that, if that part is available right now, if we have to replace that part or repair that part, so we can have all these type of work, information, right? Okay. So for example, looking at that, so you can look into that, and then we have all this different style of information in that, right? So you can see there are different pipes, and then you can have different style of information, right? So if you click on one component, it can show us the what was the submittal transmit, what's the warranty of that component, and what type of operation maintenance we have done, So this is the information we can get it like in detail for that component. So when we're talking about the 7D BIM, so it can be sustainability, it can be energy analysis, it can be energy analysis or any type. As I mentioned you, like, there can be multiple dimension based on the that. So this is the energy analysis. So you need to know that, okay, how much, what is your light feature, what are occupants, what is your window solar, what is that? So we can have a detailed information that, Basically, 7D model based analysis refer to the information driven model. There is like a qualitative, by the qualitative cost often related to tenants or user facilities, right? So we have conceptual energy analysis, detailed energy analysis, life cycle energy analysis, airflow analysis, sun and shadow analysis, climate analysis, even the solar radiation analysis. We can link that with the in a BIM model, right? So you can see that, like, this is like showing you the energy analysis, right? This figure. And then this is like you can have like the heating load, you can have the monthly cooling load, even you can, that how much consumption you are generating, from different components of building. So national urban infrastructure planning. So this is like it it's here, right? Okay, so if people know about that, so You can see that there was a lightning analysis of that. So there was energy analysis for that project, right? So BIM is not a magic, okay? BIM is not a magic, okay? BIM is not something really new. BIM is also not perfect, okay? It is not solving all the problems, but it's not only a software. It's not only, it's not like BIM is not like magic who can solve all the problem. You need to understand the process, right? It's not only a 3D model. It's not a software. It is not just for architects. It's not the replacement of people. It's like changing the work of a task. It's not only the faster version of CAD. It's something designer to do, or it's not optional. Now I think the BIM is more than that. BIM has become a very bigger picture in all the construction sector. Yeah, for example, look at this. So from 3D drawings, so this can happen. Though this looks like so, and even like this. I'm not talking the name of some place, but when I was in Pakistan, I have visited like a very famous mall, and even they have this issue, right? You will look at this column in the like in the hallway somewhere. So if we're not utilizing BIM, it can be like so it's that you have BIM is a part to make your construction very effective, right? For example, someone is dragging this, up like a box full of stones. So someone asks them, "Oh, please take the wheel; it will help you." And the other guy, "No, we are too busy." So it's not like doing the stuff. It's always like how you do the things, in an efficient way, right? Similarly, you can go on on like like either it depends upon the importance or doing things efficiently, right? I give another example, a lot of examples in my class while teaching BIM. Okay, I give you one simple example, like you are employed at some company, and now they give you 1,000 rupees every day, and no, you have to go to Peshawar to Islamabad. Are you going to go by bicycle and take 2 holidays, or you go by the car in the evening and come back on the same day just to save the money? So this more economical and more efficient. You got my point. And also in the world, everything is related to economics. Okay, there is nothing which is not related to economics. If you want to make if we are here, even like your education, your everything is related to economy, right? So everything which is related to economy, if it's anything is not related to economy, it become irrelevant. There are a lot of things which have become really irrelevant to economy. For example, now how many people have a landline phone in their home because it is not become really, or it not now become very real part of the economics. How many people have a fax machine right now? So this is that how the economics drive everything. So, what are the latest BIM trends? Now, augmented reality, AR, VR have really become important now. They're integrated with BIM. So you can see in an immersive environment, the 3D printing where you make the models in a BIM, and then it's like a robotic arm who construct these things. And then there's a cloud collaboration where the data is shared, or like, a lot of model sharing done in real time. Then IoTs are they can collect a lot of data and provide a feedback in a real time. Also the drones are become a really important part for construction progress monitoring, even like a basic surveying, like preliminary survey, or even for developing the initial designs. So there are like some famous companies like Autodesk, of course, very famous, and Trimble. Even our university, Trimble comes in our campus, and they have their own softwares, and they come and deliver lectures. All it can deliver to BIM. Then there's Bentley, uh, Hexagon, Dassault Systems, Nemistack. Even our own, even the governments are to have more safety and security. Governments have their own BIM systems. Like our own research lab, we have our own BIM platform developed for only our part, because we are mostly dealing with construction reports, so we don't want our information to be manipulated with that. And then there are a lot of BIM software: SketchUp, BIM Object, Rivet, Clash NP, Naviswork. They're like, you cannot name them all. These days. Tekla. So what's next after BIM? There was not a BIM. Now what's next after BIM? For example, if someone had not interest in 2D drawings, maybe it's really hard also for him to understand the BIM. What's next? Has anyone heard about the digital twin? So this is, we are going to finish in like, we are going to finish in like 10 to 15 minutes, like last a couple of slides, then we have answer question session, and then this is over, right? Because it's only 2 hours for that. So what's next after BIM? That's very important. Now, this is called a digital twin. Now, this is also one of my recent research areas where I have been working with Korean government projects, or with my students, develop the new trends. Because in Korea or the developed countries, they are moving from BIM to the next part. This is called the digital twin. So if you don't know about the BIM, it will be really hard to get a grip of the digital twin. So this is next level. We call it a digital twin, right? For example, BIM is a digital world. Okay, now we have as design model, and now we have the as built model. We call it BIM. Now we are going to have a digital twin where we have a digital world, which is a BIM model, and then we have a physical world where this model is created. Now we are going to make the interaction between these two things. This is called the digital twin, where they're going to have predictive maintenance. We are going to use the machine learning. There's a real-time operational data. There's a what if analytics. For example, now you have a BIM model, you develop a facility, you do the energy analysis, and now you put some sensors that interacts based on your consumption or your behavior, and they turn on off the energy consumption, right? Based on that. So now the digital twin is the future, or the next part is the BIM of the digital twin. In my lecture, I'm also going to give one more lecture about the digital twin in detail, because this is a very hot topic. So I'm going to finish this like with this, like concluding with a digital twin. Basically, it's a digital twin. BIM is not dynamic, but digital twin is dynamic. It's a living digital environment. It tracks how physical, how our virtual world interacts with the physical world, right? So it's a representation of physical asset and environment, such as bridge, car, building. Think of a traditional 3D model and more as an information model. Now, how these things interact with each other, right? Take an example of a Tesla. So Tesla is generating the 3D models, and now it is responding to the environment, where to brake. Or now we have the smart car, lane assist, cruise, auto adaptive. This is all the real-time information. So we are going to use that in our operation maintenance. Because we call it a digital model when we have a physical object and we have a digital object. So this is a digital model, which is a BIM part, we can say that. And the information flow is manual, like we put everything, and when we are constructing the model, we do that. Then there's a digital shadow. If you use a 3D printer, this is one of the example where we have a digital where we have like a physical object, and now we are collecting the information through a sensor. This is called the digital object. Sorry, not I was not 3D printer. Like, for example, we have sensors, and now they're giving us the information, and we do that. For example, in your home, if you have a humidity sensor, it is telling you, oh, your humidity in your home is too high. Maybe you can turn on the dehumidifier. Oh, your temperature, or the temperature on your AC shows you like what's the temperature inside. So then you, based on that physical object information, you are turning on some information, right? And then we have a digital object, digital twin. For example, the similar thing, now you set the temperature, and now it is tripping automatically or giving you the information. Like I told you, like even the Tesla car, it knows that when to brake based on the information, right? So this is a digital twin basic concepts, right? This was the partial BIM level 1. Now we are moving toward the integrated BIM. This is what we have, integrated BIM with every information is included in that. This is digital twin, or implementation of data digital engineering, where we are going. This is called the digital twin side, where we have level 3 of BIM. where construction, operation, client, everything
Sorry,
and
sir.
data is like linked
That
it together.
sorry,
जी
sir.
जी जी।
ये डिजिटल पिन को हम ये रियल टाइम रिस्पांस ऐसे मानों में इस्तेमाल कर सकते हैं कि जैसे ही उसको कोई रिस्पांस आ जाए तो उसको रिस्पांस खुद भी करे वो इक्विपमेंट।
Just let me finish this last slide. Let me finish. I will come back to your question, right? Okay. So this is like automated design, where you can see that here we are integral part of digital design. Here we are included with that, right? So it interacts with that, right? So thank you. Thank you very much.